boards for the rest of the in-class assignment. What was great about this is that we actually had a couple cadets come in early for AI to cover this, and I kind of figured out all the bumps already. But you have this definition. You actually have to use this definition. And don't tell me there's no.
The rest of the in-class assignment?
So there's an in-class assignment I gave on last week, and there was some. Yeah, so.
It's like plot next one.
Do you have any extras, man? Because I don't think I was.
I might. I don't know.
Absolute value of X.
Absolute value of X less than or equal to X. Absolute value of Y. Okay. We're sketching in pairs.
Cool.
I define it like this. It doesn't really matter where the 0 goes. I attach it to that one. But I've also seen it where you let x equal 0 be a separate thing. So this is the definition of absolute value. It's actually a piecewise defined function. And somehow when I took these courses as a high school student, I had an ag guy actually teaching my math courses, and he gave us this definition and he forced us to use it all the time. So I think one of the reasons I never struggled with this is that that's how I learned it. But for most of us, I don't think we get a formal definition of absolute value. You kind of just know that it makes numbers positive. And I think in calculus, you actually have this one example that they bring up that, depending on who your teacher was, they made a big splash out of that absolute value of x is a function that's continuous but is not differentiable everywhere. So it has a jagged point. Okay, so the first problem I gave you on that in-class assignment, I think, was to graph this absolute value of x is less or equal to y. I'm actually going to do this one for you so you can see it. Right, I think I'm just checking that you can actually see it inside the video. Let me do this.
Oh,
There's a glare off of it. Let me see. Don't fall asleep. All right, so for this one, what you have to do is actually draw your axes out, and then you look over here in this first quadrant. And you did stuff like this with trig functions. You know how to look at different quadrants, but here your x's are positive and your y's are positive. So you go back to this function that's defined up here piecewise, and then you map it to that area. So in this, if I look at this piecewise defined function, so this should be negative x here.
okay. I was like, what?
Glad you guys are on the ball today.
Like the same thing.
You look at this piecewise defined function, and then over here, x is bigger than 0, so absolute value of x is equal to x, and y is bigger than 0, so absolute value of y is equal to y. And so you're really graphing the function, or the inequality, x is less or equal y. And then you go back to your first grade school, wherever you learned how to graph inequalities, and you plot the y equals x line first, and you want the y values that are below the x's. SAT questions, these are like SAT questions that you guys probably had, and that's that. You get that region below. Bringing back memories?
Cool. They're foggy, maybe.
I got there somewhere. Too easy.
All right, so then you go to the this place right here, Bridget. Come on, gotta get you woke up.
I'm pumped up. This is awesome.
Yes, kind of nice to think about. I don't know when do you guys learn this stuff now? 5th grade, 6th grade, it's getting earlier and earlier. In this region, what is the values of x's and y?
Negative, positive.
So x is less than 0 and y is bigger than 0. And you do the same thing. So absolute value of x in this case is going to be minus x in this region, and absolute value of y is going to be y. And so you get your inequality looks like minus x is less or equal to y, and that would be this line right here. This is the math that you guys were all good at. That's how you did well in your SATs and ended up here. And many of you ended up in the Jedi math class. That's the reason, right? Is like doing this kind of math. So so your y's are going to be bigger than minus x, and so it's this region up here. Did I have this right? Negative x equals negative x. Yep. Yeah, y's are bigger than negative x. Yeah, that's correct. Get the idea? What do we be down here? Sam?
In the first
quadrant, wouldn't it be like the top portion that's shaded, not the bottom portion?
Y is bigger than negative x. Here's a line y equals negative x.
The, The first one.
This one? Yeah, oh, yes, you're right. Maybe I should go back to drinking coffee. Bridget, I'm just as tired as you. I'm just up here having to get that adrenaline pumping. I might switch spots with you. And you can teach the rest of the class and I can, you can wake me up. Alright, down here. You guys listen to old music. I was supposed to hate my parents' music.
I just like the song Love Shack.
That's like so.
We did talk about playing that one.
It's like such a thing. Okay.
Right, down here. What are the values? Do I need to finish this? I think you guys can take boards now before you fall asleep.
Okay.
So x is less than 0, y is less than 0. And over here, so yeah, absolute value of x would be negative x. Absolute value of y would be negative y. And don't forget, when you fiddle with your inequality, when you multiply through it by a minus sign, the inequality just turns around. SAT math. All right, go ahead and take boards and finish that one up.
Because it's less than 0.
Take notes.
So it would be that they're coming out again.